All right. Good afternoon, everyone. Thank you for joining our session. My name is Neeraja Rentachintala. I lead the product management for Amazon Redshift. I have a co-speaker, Adam Levin. He is a principal product manager on Amazon Aurora. Today, we are super excited to share with you more details about a new capability that we launched at re:Invent, which is zero-ETL integration between Aurora PostgreSQL and Redshift. So this is our agenda. First, we'll start with a very brief discussion on just operational analytics, what it is, what are some of the use cases. Then we'll dive into how AWS powers operational analytics. So what are the kind of the foundational pieces, what are the challenges that customers have today, and our vision for zero-ETL. Then I'll cover briefly some of the recent developments around zero-ETL at AWS. And then Adam is going to dive into the Aurora Postgres zero-ETL, including what are the features, how does it work, and he has a couple of nice demos to show. All right, so let's start with what is operational analytics. As customers become more and more data-driven and start to use data as a strategic advantage, they increasingly want access to near real-time analytics. This helps them to be much more proactive in understanding their core business drivers on how to increase sales, reduce costs, how to optimize their businesses. And there are several use cases for operational analytics. For example, things like personalization, so that you can offer best customer experiences using relevant data based on their own preferences. There are things like detecting fraud, preventing churn. These are all like horizontal use cases that are applicable across different industries, things like product insights. And then there are industry-specific use cases like gaming leader dashboards or things like Internet of Things. So all these use cases are, the key to enable all these use cases is to get to the data fast, be able to analyze it, gain insight, and really take action. So this is why we are working towards at AWS a zero-ETL future. And the idea is we want to make it very easy to analyze the data that you have in one system using another system without having to deal with the whole complexity of the pipeline management. And the zero-ETL theme you probably have heard. We have multiple other zero-ETL integrations that we have launched for Redshift. Here we are focusing on the Aurora PostgreSQL. So before I dive in, can I get a show of hands on how many of you have a need to analyze near real-time data from some operational database? Okay. And how many of you directly or indirectly are responsible for building, maintaining data pipelines? Okay. I have some audience that can connect to the problem that I'm going to talk about. All right, so let's talk about how does AWS power operational analytics. So to start with, first of all, AWS idea is to provide purpose-built databases for transactions and analytics. Amazon Aurora, as many of you know, is a relational database service that we have that combines the speed and availability of commercial databases with the simplicity and the cost effectiveness of open source database. So many of our customers use Aurora as the backend, data backend for their transactional applications. It's fully compatible with MySQL, PostgreSQL, so you can easily write applications to it, move your applications to it without having to make any changes. And it also comes with a bunch of tool sets so that you can build applications easily. Whether they are serverless applications, more and more generative AI applications, you can easily build against Aurora. Aurora is also a fully managed system, which means that you don't have to kind of think about the hardware provisioning, database setup, patching, backups, all these things, they're all fully taken care of. And again, the security, availability, reliability that you expect in a commercial database, but at 1/10 of a cost. And we have hundreds of thousands of customers using Aurora. So this is one of our fastest growing service on AWS. We have out of our top 1,000 customers, more than 950 customers use Aurora. So very, very popular database. Redshift is purpose-built for analytics. In 2013, AWS has introduced Redshift as the first fully managed cloud data warehouse that makes it easy to analyze large amounts of data using familiar tools. And this is a significant leap, as the traditional data warehouses were not elastic, they were expensive, and they were much more harder to tune and operate. So since then, in the last decade, we have added a lot of innovations to Redshift so that we can keep pace with the customer demands, but also expand the horizons of data warehousing use cases to high performance analytics at scale, but also add machine learning capabilities, Spark integration, near real-time analytics, data sharing, monetization. So there are a lot of capabilities that a data warehouse can offer today. A quick show of kind of numbers on Redshift. We have tens of thousands of customers. Collectively, Redshift processes exabytes of data per day, executing over tens of billions of queries per week. And Redshift offers ability to query the data in open formats like Parquet, ORC, JSON, etc. And just on the data lake, we have approximately 50 exabytes of data that is just getting scanned on an annual fashion. And we have a capability called Redshift Machine Learning, with which you can use SQL to create, train, and invoke models. We have over 10 billion inferences per day using Redshift. So machine learning is a popular use case. And then there is streaming ingestion, where from a single stream, Redshift has around 2.5 gigabytes per second throughput. And the most differentiating capability for Redshift is really its analytical performance. So Redshift offers up to 6x better price performance than the alternative systems. So it is built for analytics, so it has columnar storage, massively parallel processing, compilation caches, result set caches, materialized views, a bunch of performance features really to enable analytics. And Redshift scales with the number of users and the data. So this is just an example of a dashboarding application where you have high concurrency, so large number of queries, but each query is very, very small, so it's a low latency query. In these kind of operational analytics dashboarding applications, Redshift offers up to 7x better price performance compared to the alternative systems. Redshift again used by across different industries, healthcare, financial services, telecom, all sorts of industries and customers, they use Redshift. So we have a nice database service that can do transactions. We have a very useful product, which is the data warehouse that can do analytics. So what is the problem that we are trying to solve, right? As you can see here, many of you know, can have experienced this. You have to use a lot of components and services in order to bring data from Aurora to Redshift today. So for example, you would use something like AWS database migration service to take the data out of Aurora, put it in S3, use something like EMR or Glue to process the data, put the data back in S3, and then use something like a copy commands to load data into Redshift. And another thing we repeatedly hear from customers is Aurora is a database, Redshift is a database, but because of these pipelines in between, you have to actually pay for the compute to do things like deduplication, to do the merges, just the updates to the records. All this data you have to kind of pay for the compute in between. So what we are trying to do is, these pipelines are, what we are saying is, this kind of an architecture is really not going to help if your goal is to get to the data faster. You want to get to the data faster, start gaining insights. Maybe at that time you might realize a need for transforming the data into a different form, but to be able to do that, you need to be able to get to the data first. So this is what we are trying to do with zero-ETL, which is we want to make it simple and secure to enable near real-time analytics on petabytes of transactional data. And as a customer, you don't have to really build and manage any data pipelines. And zero-ETL integration is kind of a continuous replication. It's a change data capture based. So it's continuously, as the data is updated on the source database, the data is automatically appearing on the Redshift side. And within seconds, Redshift is going to have the data after the transactions are committed on the Amazon Aurora side. And one of the benefits of the zero-ETL integration is many of our customers have one database for each of their applications. So they have a Aurora database instance for one application, a second application has a different instance, and many of our large customers have hundreds and thousands of these Aurora instances. So one key benefit of zero-ETL integration is you are able to actually bring the data from multiple Aurora databases into a single data warehouse so that you can actually get holistic insights across all your data, all your transactional data. And once the data is in Redshift, Redshift has a very nice feature called data sharing, with which you can actually share live and transactionally consistent data across multiple data warehouses. And these data warehouses could be within the same account, they could be in different AWS accounts, they can be in different regions, they could be even across different organizations like your customers, your partners. So this live and transactional consistent data sharing is very handy because now you landed the data in Redshift, it's near real-time data. Now you are able to share this data seamlessly across your organization without having to worry about, again, copies and movement of the data. So combining the zero-ETL with data sharing, it can be a very powerful mechanism to share the data in an easy fashion across the organization. And Redshift, of course, have other capabilities. For example, on the left side here, zero-ETL is one way to bring the data from operational databases, but you probably have some data in S3 data lake, some data coming from a different system, and you might have some streaming data, some events data that is streaming from a streaming service. And then the nice thing is in Redshift, you can actually join all this data, your data lake data, your streaming data, your operational data coming from Aurora. And Redshift is even integrated with AWS Data Exchange, so you are able to actually access third-party data sets and join with your first-party data sets. And then on the right side, you have all types of analytics. You have business intelligence and the BI tools like Tableau, MicroStrategy, different kinds of BI environment from which you can access the data. You can build data applications, you can do machine learning, and you can do things like Spark using the EMR and Glue directly on top of the Redshift data. The key point is once you have the Redshift data in Redshift, you have all the power, all the rich analytics of Redshift accessible for your users. So let's talk about some of the recent developments in the zero-ETL. So we have launched zero-ETL last year as a beta at reInvent. Later we opened it up for a public preview. We have lots of customers that have tried out and provided the feedback. And then we have launched it as a generally available capability, Aurora MySQL I'm talking about. So that went generally available a few weeks back, I think 5-6 weeks back. So in the zero-ETL of Aurora MySQL, we have added a number of capabilities, for example, expanded region support. Now we have made the APIs available. In the preview timeframe, it was primarily accessible through console. And then we have improved the getting started experience, so it's much more seamless now to try out the zero-ETL integration. We have added things like events. So whenever the integrations get created, you can actually subscribe saying, okay, tell me when the integration got created, when it got changed. So all these things you can subscribe to. And we have got a lot of requests for Aurora MySQL around JSON support, so that is added as well. So Aurora MySQL is generally available. And we have a number of customers that are using successfully the Aurora MySQL zero-ETL integration. Just a couple of examples here. Money Forward is a financial management platform. And as you can see here, they talk about the real-time data synchronization between Aurora MySQL databases and Redshift. Previously, it could have taken them months to set up an analytics environment that they were able to do very, very quickly. Another important point is with zero-ETL integration, the replication is happening at storage layer, so there is no impact to your actual production environment. So that is an important benefit. And Woolworths, another customer, similar feedback, which is it could have taken months to develop the ETL pipelines, much simplified experience, and also because of the near real-time data, they were able to analyze their event data much, much faster. So at reInvent, we have extended the Aurora MySQL zero-ETL integration to more data sources. Now we added the support for PostgreSQL. The nice thing with the zero-ETL integrations is they all have consistent experience. So whether if you are using Aurora MySQL, Aurora PostgreSQL, the experience of zero-ETL is pretty similar. You just create an integration. We are going to show that later in the demo. Specify a source, specify a target, and that's it. and that experience is uniform across the different data sources. So all the benefits that we talked about from a zero-ETL perspective, they all apply to the Postgres as well, simplifying operational burden, near real-time access, and once you have the data in Redshift, being able to do analytics at scale. And the PostgreSQL zero-ETL integration is also storage level replication. So the benefits that we talked about not impacting the production cluster, they're applicable here as well. We support the DML, which is insert, updates, deletes kind of operations, as well as metadata operations, which is adding new tables, removing tables, adding columns. So both data and metadata operations are supported. We automatically map the data types. So all the standard things that you would expect in a replication kind of a capability, it's all there. It's taken care of. So we have the preview available in APG 15.4 version onwards. We have it available in USES 2 to start with, so you can try it out there. And we already have many customers that are getting ready to try it out. Just a couple of examples here. And the patterns are pretty similar. So in the case of ICMS, who is a talent acquisition company, so they are doing currently nightly one-time batch ingestion. Now they are able to move to near real time. So the key is near real time, eliminate the data pipelines, and without having to impact anything on your production clusters. So with that brief intro, I want to hand it over to Adam to dive into the APG specific details.
Thanks, Niraj. So now that we've talked a little bit about, high level, what's the value of getting data into Redshift, what are the capabilities of Redshift, and a little bit about the capabilities of the Aurora Postgres zero-ETL integration, I wanted to dive in a bit and look at some specifics. What does it take to set up an integration? What are the challenges that are specific to Aurora Postgres? And then, I've got a few demos to show in terms of, the setup experience, near real-time replication, lag, and then also, what does it look? What can you do with the data once it's over on Redshift? So we'll break this up into three sections. First, we'll talk about how it's simple to set up an integration. Then we'll talk about how it's simple to manage that integration, and we'll sort of take a peek under the covers a little bit and look at what's going on behind the scenes once you click that Create Integration button. And then we'll talk a bit about what you do with that data once it's in Redshift. Sound good? Cool. So when you want to, just double clicking on that chart that we were looking at earlier, like, you've got a bunch of pieces in place that you need to go and spin up when you want to get data out of an operational database and into an analytical store. You need to put a team together. You need to go get infrastructure. You need to figure out, like, is this going to be batch? Do we need near real time? How do we deploy this? How do we monitor it? How do we ensure that it is healthy? Who's getting paged in the middle of the night if something breaks? All of these things can take days, weeks, months, a year to really sort out. And that's because there's a bunch of different components that are needed. And there may be reasons that you want to go and do this and build all of this out. If you need to, if the sort of level of complexity of your workload isn't a good fit for a zero-ETL integration, then you may still need to do this. Like, I'm not trying to say that a zero-ETL integration is a fit for every single use case, but for getting data from Aurora to Redshift, it works very well. And that's because we take all of that stuff that's on the top of this list and we manage that for you. You basically come in and you tell us where you want the data to come from and where you want it to go and with what types of permissions, and we take care of all of that for you. And this lets you get started in minutes. And so even if this is just trying to get a POC, what can I do if my data was in Redshift? It's a lot easier to go and spin up and create a zero-ETL integration in a few minutes than to go build a whole bunch of data pipeline to move your data. So when you come to create a zero-ETL integration, you first need to figure out, is this going to be, does your Aurora cluster and your Redshift data warehouse live within the same account? Are these different teams? Are they in these resources in different accounts? The good thing is that we support all of these modes. And so you can specify a resource policy by which on the Redshift side, data is accepted or not accepted from certain accounts or certain clusters, and you can have really fine-grained controls over the authorization and the policy when it comes to where data is moving. This is particularly important if you've got two separate teams managing operational databases and analytics databases, where one team can't just say, oh, I'm going to put my data over here. And so you can set these things through IAM. The next thing, and we'll go into a bit more detail, is really the simple setup experience. You go and you create a database cluster. There's a few parameters that need to be set on that database cluster. As Neeraj mentioned, this is a change data capture based system. So on the Postgres side, we're using Postgres logical replication, but we've made a number of improvements to how logical replication works, and we've pushed a lot of that processing down to the storage layer to free up compute on the compute node. And then ongoing monitoring and error reporting. We provide fine-grained reporting of events, of issues. We'll tell you exactly which table has an issue if there is an incompatibility or some sort of data type. One of the benefits of Postgres is that it is extensible. And so things like extensions and custom data types, if they aren't able to be replicated over, we'll come and tell you that. So it's no surprise that something may or may not be there. Okay, so let's take a look at the initial setup experience. So what we've got here on the right-hand side, I've got a Aurora Postgres 15.4 cluster that's been created in the US East 2 preview region. And so when everyone goes and tries this out after this session, and you open up US East 2, I want you to click on the RDS console and then scroll down to the bottom and click Preview. And so at this, this was just launched in preview at reInvent, and so it's in the preview region. I just don't want anyone to be confused if they go looking for this in US East 2 for Aurora Postgres. And so we've got the cluster set up here on the Postgres side, and similarly, we've set up a Redshift cluster in the preview track in US East 2 as well. So we are going to go and fill this cluster with some data. So first step is to create a database. We'll call it APG source ETL. And then we're going to go and create a few tables and fill those tables just with some sample data. This is a fairly simplistic example, but just to show that when we create the integration initially, all of the existing data is copied over, and then any changes that happen after that integration is set, those things are replicated over as well. And it's really sort of this simple. So while we're creating a few tables and inserting some some values into those tables, I'd like to welcome Bob and Alice to the database. It's worth mentioning that because this is a logical replication-based system, you do have to enable logical replication on the cluster when you go set it up. And specifically, for zero-ETL, for Postgres, we've introduced enhanced logical replication. And so what that instructs the cluster to do is to use a different pathway where we're pushing down the processing of those logical replication files and the decoding into storage and removing a lot of the compute intensive work that's required. And so as much as possible, we have a sort of vision to offload as much as possible to storage. So we've inserted some data into our resources table. We've got a keyboard, we've got a mouse, we've got a display, and then the last table we're going to create is a rented resources. It's important to note that each of these tables requires a primary key. So that's important. It's good general hygiene anyway. But it's important to create your database and your tables with a primary key for a zero-ETL integration. So just inserting the last bit of data. And then we are going to go over to the console and click on the, almost there. One last table. We're going to create our returned resources table and set that one up as well. So just creating a few examples that we'll play with in Redshift on the flip side of this all. The other aspect of this is that today, it works just with provision clusters, but as if you take a look at on the Aurora MySQL side, we support both serverless and provisioned, and so we'll get there as well on the Postgres side. So now that we've set up our database, we click on the zero-ETL integration tab, we scroll down, we click Create a zero-ETL integration. We're going to name that integration with whatever we want. We'll select our source database cluster. And because this is Postgres and Postgres's resource model, you can create multiple databases within a cluster. You need to tell us what that database is called. The mapping is one database per integration. And then you saw us select the target destination data warehouse. You can optionally assign tags to it. You can specify your own encryption key. And then we clicked Create the zero-ETL integration. And as you can see on the final screen here, under Status, it shows us creating. Typically, the process takes 20 to 30 minutes. And so we're not going to sit around and wait for that. But I will tell you a bit about what's going on behind the scenes while the integration is creating and what's going on once you click that orange button. So you've got your source cluster. In this case, it's a 15.4 cluster. And as has been said many times about Aurora, one of the key innovations is the separation of compute and storage. And really, the log is the database. And so we write the write-ahead log, the wall, down to storage, and we push all of the processing of that wall and writing the page files of the database down to Aurora storage to offload that from the compute node. So you've got your transaction log going down to Aurora storage, and then you go and you enable logical replication. Logical replication in Postgres, there's replication slots to manage, depending on what's going on. There's resource contention. With any system that you're building yourself, you're going to have to go through the compute cluster to get your data in and to get your data out. And so we thought, well, why can't we get the data directly out of Aurora storage? Why do we need to go through the compute cluster when it's time to do any of this work? We've got storage that's managed by AWS for Aurora. We've got storage that's managed by Redshift, or managed by AWS on the Redshift side. Why can't we have these things work together on your behalf? So when you go and create that integration, we take an export of everything that's in your database. We use a performance optimization that we've made to the export function in RDS. We get that data out, and we load it into Redshift. After that's done, we've been collecting the change data logs. And so we're able to go, and anything that's changed while that database was exporting and loading that initial seed data, we're able to go catch it up based on the changes that have been stored down using logical replication. And we've built a customized set of streaming compute servers to read the data directly from Aurora storage and then push that over to Redshift. And so this is a fully managed set of functionalities that you don't have to worry about. You don't have to think about spinning up that compute or managing that just to move the data out of Aurora storage. And while all this is going on, we're monitoring the entire system. Logical replication in Postgres has some limitations, and particularly around DDL. And so with zero-ETL integration, we're able to support some DDL, and when we encounter a DDL that isn't supported via logical replication, we intelligently are able to go and reseed the data. And so we take another export and we load that into Redshift to make sure that the data and the data structure, the schema on the Aurora side is the same as that on the Redshift side. And all of this is happening behind the scenes, automated. Things are recovering as needed, which brings me to the next point of resiliency. There are multiple points in this system where we have built in resiliency, where we've built in automated recovery from issues. So you don't have to worry about it. So you're not worried about getting paged in the middle of the night. So you're not worried about what happens if something breaks. And I'll just touch on a few of these. So first, on the Aurora Postgres side, you can create multiple read replicas of your Aurora Postgres database, and they are all connected down to the same storage layer. And so if something happens to one of those instances, you can seamlessly fail over to a read replica. And this has no impact on the zero-ETL integration because everything is done at the storage layer. Similarly with Aurora Storage, when you write data to Aurora Storage, we copy it out and we write it six different places across multiple AZs. And so if something happens to one of those storage nodes, you've got 5 other copies of your data. For every write that comes in, we wait to have a quorum of at least 4 of those writes before we acknowledge that write to the compute instance. Similarly, on the Redshift side, Redshift Storage and Redshift have capabilities to enable resiliency and high availability. So even in the face of issues, you're able to fail over and get back up and running very quickly. And then in the middle, that CDC streaming fleet I spoke about, that's fully managed for you, and it's built to be resilient. And so if something happens to the compute, we switch over to another compute instance, and because the change data capture log, that logical replication log, is stored in Aurora storage, we just catch up. And so whatever files we didn't read while in the few seconds that it was taking to switch over to a different compute instance that's streaming data out, we just go and we catch up those changes and push those over to Redshift. And we're always able to reseed the database as necessary. So we're able to re-export the database and the tables and push those over to Redshift. And as I mentioned, all of this is happening behind the scenes automatically. and without any intervention. We do report when things happen, and so you can see lots of details around what the system is doing, where it encountered issues, when you can report on lag. And so, for instance, with the streaming server, if it needs to fail over to a different server, you may experience that as an increase in lag. But you can see in the Redshift console fine-grained metrics around lag and how that is shaped over time. So, going back to the console, we've got our integration. You can see the status has changed to active, and let's play around with this a little bit. Let's take a look at the system. The first thing to do, though, is the integration is not quite complete. Going back to what I was saying before around IAM policy and having fine-grained control over data coming in and data going out, you need to accept the data. So the Redshift administrator or the Redshift user needs to accept the integration into the Redshift data warehouse and create a database that is connected to that integration. So we're just going to grab our integration ID, which is just a unique identifier, and we're going to say create database RS Redshift target ETL from that integration. And now we've got our database over on the Redshift side. So we'll just connect to that database, and let's take a look at what's there. So select star. We'll hit run. And there's Bob and Alice. They've made it over from Aurora to Redshift. And as you can see, that's exactly what's on the Redshift side. Now I know this is a video, this is a recording, but this was recorded live. So this is real data happening in real time as we're watching it. So let's take a look at another table. We'll take a look at the resources table. It's matching keyboard, mouse, display. The quantity in stock is 10, 5, and 3. So that matches as well. And now let's see what happens if we insert some new data. So we're going to welcome Noel into our store. We have a new hire, and we will, Noel's right there. So a couple seconds have gone past. Let's see if he's made it over to the Redshift side. And there he is. And so when we talk about near real-time operational analytics, it's a few seconds to get data on an ongoing basis, not a batch, not a daily batch or a weekly batch, but on an ongoing basis from Aurora over to Redshift. So similar thing works when you want to go create a table. So let's go create a new table. And so this is DDL, so a new table. We're going to create that. This is getting processed through logical replication running in Aurora Postgres using the optimizations that we've made for zero-ETL. And so we'll go create that table. We'll insert into that, that new table a couple of records. Give that a chance to finish. So, we're going to review the mouse. Everyone has their favorite mouse. This one worked well. We've inserted that. So let's go take a look at, we've created a brand new table. We've inserted some data into it. A few seconds later, that shows up in Redshift. And is it there? So it hasn't gone there. So just to reemphasize the point that this was recorded live. Lag is variable depending on the processing. What is getting inserted into Aurora and the processing that needs to happen. The lag can vary from a low single-digit seconds up to double-digit seconds, but there is some variability there. But now that we've waited a couple seconds, the data is there now. And so we will create another table, test resource cleanup. We're going to go through a couple steps to add data. We will show a transaction that is inserting, that is, we will add data to an existing table and then truncate a table, and we will show that these things are all getting replicated over. And so this is really powerful when you want to have all of these changes and support application development with Aurora as an operational data backend, but then you want to be able to get all that data out and analyze that data on the Redshift side. Now, this is a mirror image. So all of the data that is in your database within Aurora Postgres is getting copied over. And we have heard lots of feedback around the ability to filter out particular tables from a database, particular columns from a database. And so that is one area that we've heard lots of feedback from. And so we appreciate that feedback. And it's something that we are researching. So all of this is happening on the back end. We've now updated an existing table. We have incremented some of the stock based on new inventory. We're going to drop a table. And so drop changes are also replicated over to Redshift. And the reason we're going through so many of these sort of small examples is because this is hard to do. Like, Postgres logical replication doesn't support a lot of these things right out of the box. And so as much as possible, we're trying to build in functionality to support the breadth of DDL commands that you can throw at Postgres and be able to replicate those, the impact of those changes over to Redshift in a performant way. And so we've dropped a table. It doesn't exist anymore. It's removed from the database on the Redshift side. And then we ran this transaction to set the stock of our resources table and drop that other table. And now we've got our newly updated resources table on both the Aurora side and the Redshift side. And now we're going to drop the return resources, and you can see that it's replicated over on the Redshift side. So just a variety of examples of common things that you might do to a database: inserting data, updating tables, adding a table, dropping a table, a transaction to process to touch multiple tables at one time. And all of these things are getting replicated in near real time over to Redshift. And so that's great and all, but the point is, what do you do with the data once it's in Redshift? And as Neeraj was talking about earlier, Redshift supports a wide range of really powerful analytics capabilities, from being able to share data out to other parts of your organization, the integrations with other AI ML services, materialized views, and being able to aggregate data from multiple data sources into a single view. And so let's take a look at a couple of those briefly. And so in this next demo, we're going to create a materialized view. This is a different data set. So this is just a sample ticket sales demo set. We're going to create a materialized view over the data to create a materialized view. We're going to create a model, an ML model, based on that data that forecasts sales for the next month. And so excuse me. Initially, we'll create this materialized view, daily sales by event. We input a number of columns there, quantity sold, price paid, the event sales amount, the date. And you can see that we've got data from the beginning of 2022 out to the end of 2022. But we want to know, let's say it's the end of the year. We want to know what our potential sales in January are going to be. And so we can use this type of pattern to generate some forecasts that we can then use as the basis for decision making. So we've created our view, then we're going to use the forecast function in Redshift ML to create a model. And using that model, that's when we will go and pump this data into it and generate a number of forecasts across a number of different runs of the data at different confidence levels. And so that's what you see down below here, where we've generated a table based on the model, and we are displaying the list of potential outcomes. And so this is just a small example of the capabilities. You've got operational data coming in. Things are changing quickly. You can create this type of system to constantly be updating a forecast or whatever is relevant to your business. So you can keep feeding these analytic systems with real-time operational data in near real time. And that's really the power of this system, is leveraging what each of these systems is built for and being able to move data between them in a very seamless, easy way. So just taking a step back here, the zero-ETL is part of a vision. We want to enable you to perform analytics on your transactional data without building complex data pipelines. We're at the beginning of this journey. By freeing up your teams to focus on getting value out of the data instead of sort of operationalizing the data, you can then take leaps forward in your cloud data strategy and get to better data-driven decision making, use this data to feed into other applications and other use cases. And as you saw at re:Invent this week, we've announced a number of new zero-ETL integrations, and we're really just getting started here. There's a number of other zero-ETL sessions that are talking about other source and target pairs, such as RDS MySQL. This session has been about Aurora Postgres, Aurora MySQL. There's a couple sessions as well. But this just gives you sort of a glimpse into the vision, and we think this approach is working well for customers. But we'd really invite you to take the public preview for a test spin. Let us know what you think. Let us know if it works for your use case. Let us know what else you want to see out of the Aurora Postgres zero-ETL integration with Redshift. And it's in preview today. You can go try it out. And then, as we work towards GA, we'd love your feedback. So thanks for listening. And please don't forget to complete the session survey in the app. And we've got about 10 minutes, so we can take a few questions if you'd like.